Hello, welcome to my channel and welcome to my website. My name is Daryl and this is Programming in Any Language. The website is www.black-duck.com. It's where you'll find all my videos organized in logical order. If you have two-dimensional arrays, why not 3, 4, or even 32? Yes, you can have a 32-dimensional array in C#. Why you would need to go that deep, I couldn't say. When I was first learning arrays, I was hard-pressed to understand why I would need 3. Didn't take long to see the light. Multi-dimensional arrays are very important to the gaming world, but they're also important to the business world as well. This video will show you how to set up a 3, 4 dimensional array, but it will do more than that. It will show you a sound example as to why you might need a 3 and 4 dimensional array. And later, this will get supported by creating a 2-dimensional array app that will then be converted to a 3-dimensional array app, and finally a 4-dimensional array app like the one appearing on the screen now. Multi-dimensional array apps can be confusing if you charge ahead and just try to put one together. But multi-dimensional arrays cause a certain degree of complexity because of the need of nested loops going 3 and even 4 or more levels deep. Once you understand how a 4D array is used, this all makes sense. Here, take a look at this. Okay, let's take a look at multi-dimensional arrays. We've worked with single-dimensional arrays, one-dimensional arrays so far. We've even looked at two-dimensional arrays. And we can go beyond that. We can go to 3, 4, 5 dimensions, all the way up to 32 dimensions in C#. As you remember, a two-dimensional array is nothing more than a spreadsheet. It has rows and columns. Very, very straightforward and simple. The difference between it and a spreadsheet is your rows are going to start at 0, and your columns are going to start at 0. We're not going to use A, B, C, D, but it's going to be 0 and so on. If we look at it and compare it with a single-dimensional array, it looks kind of like this. Here I've got a single one-dimensional array called string first name. Here it's got 10 elements in it, starting from 0 through 9, as you can see. We've got names in there. It's called str first name. And over here we've got str last name, another single-dimensional array, one-dimensional array, going from 0 to 9, with last names and str last name in it. And you can compare that to a two-dimensional array, which looks like this. Here's a string full name. We've got 10 too. It's got 10 elements by 2 elements, so we've got really 10 rows and 2 columns, 0 and 1 going through there. And you can refer to any one of these things by string full name with their 2 indexes or parameters to find out which one it is. Is there a benefit between the two? Yeah, you're using one name here, you're using 2 names here, but the concepts are the same. Not too much of a difference, other than the fact that you can get through one thing. But as you begin to build on this and build them bigger and bigger, it can get more complicated as you add more dimensions to it. Now, a 2-dimensional array does have some advantage because it begins to look like records. If you think of each row as a record and each column as a field in the record, you have the beginnings of what might be considered a database or a table in a database looking like that. So it's important to think about this. Single-dimensional arrays are great. Two-dimensional arrays are also great, and they're fun to use. And you can even go beyond that. A two-dimensional array, as I already know, is like several arrays put together. It can store multiple sets of data. It can be illustrated by a table with rows and columns. The row is horizontal, the columns are vertical. The rows and columns are numbered 0, 1, 2, and so on down the line. You do not have to use the words row and column. That's something that just seems natural because they are in rows and columns. If you were using a baseball scoreboard, you might want to call it team and innings and use it that way. Team 1, team 2, and then innings 0, 1, 2, 3, 4, and so on down the line as you go across it. So it's not, you aren't restricted to using these particular words, but they are great placeholders when you're setting up something like an array, a two-dimensional array like this. You declare the 2D array very straightforward. The two-dimensional array requires 2 size declarators. The first is for rows, the second is for columns, as we already learned. And below we're declaring the amount variable references to a 2D array of doubles. 3 defines the number of rows, 4 defines the number of columns. You can see it down here. The namespace is 2D array. We got our class here, and we're rows 3, columns 4. We're using constants here. I sometimes just use the numbers themselves. I don't even use the row and column link. I just put a number in there. And then we have the bracket with a single comma in there, another bracket. The single comma denotes a two-dimensional array. and we're calling it amounts. And we say new double, rows and columns. We pop that in there, and this actually declares the array and sets it up for you, and you're ready to go. Once you've got it set up, each element in the 2D array has two subscripts, one for rows, one for columns. Once again, elements in row 0 are amount 00, 01, 02, 03. We're looking at each column as we go across. And in row 1, it's 01, 0, 11, 12, 13, and so on. To get through that. And it looks kind of like this. We just put it in the grid. The thing is, you can actually use the word amounts once and then apply these indices to them to get through. That's where loops become in very handy when we're trying to navigate through an array, whether we're reading one or we're writing one or whatever. This is what helps. You can see the loop being applied here. We can initialize an array with zeros if we want by simply saying use an I counter. As long as it's less than rows, we'll increment it. And then a J counter, which as long as it's less than columns, we'll increment it. And then we'll assign amounts I, J, or 00 initially to 0. Then 01, then 02, then 03, then 10, 11, 12, and so on. And we'll fill it with zeros and make that all happen. You can illustrate this in an application. This is a fairly straightforward application. It's nothing very large, but we're looking at assets and liabilities. If you have assets, you subtract your liabilities, that gives you an equity. And we're looking at quarters 1, 2, and 3. You could certainly go beyond this and make it a budget and look at months here. Instead, look at 12 months. In a budget with instead of assets, liabilities, and equity, we could put in all the different income we have in the top, maybe, and all the expenses we have down below, and instead of a very, very large grid if we wanted to. But this keeps it kind of straightforward and simple by looking at it this way. It'll help us to understand the two-dimensional array and how we can increase it to become a three-dimensional and a four-dimensional array. How's this looking running? Well, I've got the program running right over here. We're going to try and build this later and get an idea of what it looks like when we actually try to do this thing. But here we have the actual program. When you start it, it comes up reading a file that has these numbers in it and puts those numbers into the array. And then the array displays them on the board here. If we unlock the grid here, as you notice, I can't type anything in, but if I unlock it, it opens these things up, and I can literally put in 99 right here, for example, and then tab down and put the 15 in here. Hit a tab again and make this 67 and make this a 10. And if I want to quit, I can lock the grid at that point in time, and it does the math for us. 99 minus 15 is 84. 67 minus 10 is 57. These guys are still there. And we can save that file. And it's written to disk, and it sits out there in a grid someplace, and we can actually make use of it. This is that grid, the numbers we actually saved here. I didn't put in any doubles. These are doubles because they're brought in. In fact, let's do that real quickly. We can certainly make that change. We'll go back to the application. We'll unlock the grid, and I'll put in 99.23 and just leave it like that and lock the grid. Now you see 84.23 being saved there. I'll save that file. It's been saved to disk. I'll go back out there and get it again. And now you can see that file has been saved as 99.23 sitting there. 84.23 has been sitting there as well. So it does that. It saves it out to disk, and you get a very straightforward, simple, small text file that's holding a 2D array that looks like this. It's got 3 rows and 4 columns. Now let's go beyond this. Let's go beyond this and look at the three-dimensional array. A three-dimensional array is nothing more than multiple two-dimensional arrays. We have spreadsheets sitting on the side. And you can do this. You can set up a spreadsheet, and then you have little tabs at the bottom of the spreadsheet where you can create other spreadsheets and go on down the line. I might do this in fact, I do this. I have a budget I use, and it's got all my expenses, my income, and it's got my months on top. And then I have last year sitting back here and the year before sitting back here. So I have my three-dimensional array that way, but it's in a spreadsheet format. It's not in a program format. We can put this in a program. And we do that by a three-dimensional array is nothing more than several two-dimensional arrays connected. They can hold or store multiple sets of data. They can be illustrated by a set of tables with rows and columns in each set. A set is an index assigned to each array. The row is horizontal, columns vertical, and the rows, columns, and sets are numbered 0, 1, and 2. And you can see this down the bottom. If this is basically a spreadsheet where we have the 0, 1, and 2 sitting down here, where we can tip on any one of these things, and a different two-dimensional array will pop up. So it's really, a third dimension is really controlling what the two-dimensional array is going, which one's going to appear to us, which means we've got these 12 items here, and times 3, or what is that, 36? 36 different elements inside our three-dimensional array. Only 12 are going to show it at any given time on this particular application. Again, rows and columns don't have to be called rows and columns, they call something else. And set doesn't have to be called set. It can be called something else like year or something of that nature. Three-dimensional array requires three size declarations. The first is for sets, the second for rows, the third for columns. And below we declare the amounts variable. Once again, the same array we set up in the last set, when we look at the two-dimensional array, we're calling it amounts. It's a variable that's going to reference a 3D array of doubles. And here we have defining 10 sets and 3 numbers of rows, 3 columns. So we've got 12 times 10, which is going to give us 1,200 elements in that array. It's quite a bit. 112 elements in that set. Let's do it that way. 112 elements will be inside that whole text file that we would actually save. But we'd only see 12 at a time. Again, the namespace is sitting up here. We called it a 3D array when I set up the program. I'm using constants again. Sets is equal to 10, rows equal to 3, columns equal to 4. So nothing's changing here, but I'm adding this set piece right in here. Now notice the doubles down here, comma, comma. The double comma represents a three-dimensional array. This identifies the program that we're creating a three-dimensional array. And we set it up, call it amounts, set up a new double. We're going to call it sets, rows, and columns. So those 3 variables are going to pop in here. Again, you can use the numbers themselves. You don't have to use sets, rows, columns. You can literally put 10, 3, and 4 in here, and you're fine. It'll establish the array and go from there. When we reference these things, accessing the elements in the 3D array, each element in a 3D array has 3 subscripts, one for sets, one for rows, one for columns. And if we're looking at set 0, row 0, we're looking at 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. Notice that these pieces right here are the two-dimensional array. And this is representing the one dimension, the third dimension in the array. If we look at set 0, row 1, we're 0, 1, 0, 0, 1, 1, 0, 1, 2, 0, 1, 3, and so on down the line. So you're going across that. If we look at it, if we look at set 0, how it's actually defined with assets, liabilities, and equity, we're looking at amounts. 0, 0, 0, 0, 0, 1, 0, 0, 2, and so on down the line. And you can see the 1s and the 2s and all that. So not all that different from the two-dimensional array, except we do have that extra element in here because it's set 0. Where are the other ones? We're set 1, set 2. They're not showing right now. They're in memory, but they're not showing on the grid at this point in time. We need to use a loop again to work this. In this case, I set up an initialized array set of loops to actually go ahead and put 0 in all of the elements in the entire array, all 120 elements. We do that by setting h as our first counter, which is going to be as long as it's less than years, which we're setting up as the 10, and we'll increment it by one at a time. Then we'll want to do our rows and our columns. So it's going to go through there and make each column 0, 0, 0 is going to be equal to 0, then 0, 0, 1 is going to be equal to 0, then 0, 0, 2, 0, 0, 3, 0, 0, 0, 3 is going to be equal to 0, and then it's going to increment I. So it's going to be 0, 1, 0, 0, 0, 1, 2, and 0, 1, 3 will be equal to 0. And finally, it'll increment it again. It'll bounce this thing up to the third column, and we'll get through. Finally, when we finally get to the second row, we'll go through that process in the third row, and then finally when we hit our max row, we'll increment our year and start all over again with these particular loops. So that'll allow us to place 0 in every single element in our 120 element array, our three-dimensional array. But our application will only show the current one. And notice how we can actually do this. We can go to any year we want now, because that's where the 10 piece is there, and actually show those numbers sitting in there. Let's take a look at this application. This is the three-dimensional array. You can see the numbers are there. It's loading it right away. If I go to any given year, I can go to 2021 here, and a complete different set of numbers will pop up in our grid. I can go to 2022. Another set. This is undone. There's nothing in here. We can unlock this, and we can begin to put numbers in here. So I'll put a 15 in here, and I'll tab down and put a 10 in here. Let's go ahead and put in $1,245.15 in our assets for quarter 2, and let's put our liabilities. We're only $59.22 in here, and we'll leave this sit. We'll unlock the grid now, and it'll store those numbers. I can save this. It's gone. I can exit out and bring it up again. It'll automatically read the file and bring in those numbers that were there. So they're all sitting there. And we'll go out to number, or I think I did 2022, and there's our numbers. 118593 is our answer there. So it works the same way as a two-dimensional array. It allows you to keep these assets and liabilities and equity, but it allows you to give that third dimension, which allows you to put in a year. So this is where the application could have some benefit, make some use for you to actually store things in a nice, concise way and be able to get to anything in a 10-year period in this particular case. What does that three-dimensional array look like when it's stored out on disk? It looks like this. As you can see, we've got a lot more elements in there, and if I just scroll down here, there's a lot of them I didn't put in. I didn't put stuff in there. I did put stuff in the later ones, but there's 120 different elements sitting out in that file that's keeping track of. So that loop allows you to save the data and bring it back in the order that you want to have it, and allows it to be assigned to these particular quarters and make it all work right. So that's how a three-dimensional array works. Let's I shouldn't say let's complicate this some more. It does seem complicated, I think, when you look at arrays, three-dimensional, four-dimensional. What am I going to need them for? But when you start to see an application where it makes sense to use, it does make some sense. We can go to 4 dimensions if we like. The four-dimensional array, again, looks like the three-dimensional array, which looks like the two-dimensional array, but we're combining it all and applying them to file cabinets. So think of this. We have that assets and liabilities and equity for a particular year. We decide to have a bunch of years in there. Okay, so now we have 10 years worth of data, 120 elements, of which we're looking at 12 at any given time as we look at 1 year. But now assume you're an accountant and you're doing this for a bunch of clients. Well, you can start to assign these things to different companies and allow your one program to store the data for all of these companies that you're working with, Acme, Google, 3M, YMCA, and maybe others, and have it all in one particular spreadsheet. Well, how do you do that? A fourth dimensional array becomes involved there. So, and you know, if you notice, I said it can be complicated, but if you start to go from the concept of the two-dimensional array and increment the dimensions as the need arises, you can keep track of all this. The programming piece gets to be complicated. We'll go into that later. We'll go through this and actually build this thing so you can see how it's actually done. But a four-dimensional array, 4D, looks like several three-dimensional arrays connected. They can hold and store multiple sets of data. They can be illustrated by a group of companies, each containing a set of tables with rows and columns in each set. So we have rows, we have columns for the vertical, we have a set index for the 2D array, and a group which has an index assigned to each 3D array. So the set represents each 2D array, the group sets each 3D array. And so the row, column, set, and group are numbered 0, 1, and 2, just like everything else. Everything starts with 0 and goes on forward. You're looking at the same graph we had before where you're seeing the two-dimensional array with rows and columns here. We have the three-dimensional array showing us the different sets it might have. And we're adding a group to each one of these things. So we can have the whole set being out there with every group has all 3 of these guys. This group has another 3 of these guys, and so on the line. So each group will have 120 elements. And the number of groups you have multiplies that 120 by a number as well. So let's go forward. The four-dimensional array always requires 4 size declarators. The first is for group, the second for sets, the third is for rows, and the fourth is for columns. Again, the word group, sets, columns, and rows, you can use whatever you want there to make it happen. Below, we're declaring the amounts variable referencing a 4D array of doubles, where 5 defines the number of groups, 10 defines the number of sets, 3 defines the number of rows, 4 defines the number of columns. And we're using, again, constants in here, but I'm setting my group up here as 5. I might want to use the word companies here instead of group for the application you were seeing a few minutes ago. We're using sets equal to 10. We could use years again for that particular thing. Rows and columns, we can use it just like this. We could make columns quarters if you wanted to. We wouldn't have to use the word column, but this is fine. It works this way. And now notice this important piece right here is the 3 commas down here. This tells us that we're going to have 3 commas or 4 indices in our amounts array that we're setting up as a new double: group, sets, rows, columns, all being identified here. Again, we can use the numbers rather than this, and that sets it up. Each element of the 4D array has 4 subscripts, one for group, sets, rows, and columns. If we looked at group 2, set 0, row 1, row 0, it's 2000, 2001, 2002, 2003. Again, this last piece is the 2-dimensional array. This is the 3, and this is the 4th one that's going in there. So you can see we're going to go out and just kind of create a 4-dimensional array on the fly, just because you wanted to. It can be a little tricky to get at and work. As we're getting in, if you can see these things assigned now, we're looking only at the 2-dimensional array grid that we set up here, and we're applying certain elements into it. In this case, our 2-dimensional array pieces are sitting over here, and in this case, we're looking at year 0, whatever it happens to be, 2022, whatever, for company 2 is what's happening, and that's what you're actually seeing here. So that's all being set up here. You can apply it and set up this entire array by filling with zeros by using, again, 4 nested loops in here. G, I'm using companies. As long as G is less than companies, which I think we define as a 5, it's going to go through this whole set right on here 5 times. It's going to go through the years 10, these things 10 times, and this thing, of course, 12. So we got 12 times years is 10, which is 120 times 5. So we're getting up to around 600, I think it is. 600 elements would be inside this particular array when we get done with it. Again, this is where it can get tricky, but if you take it slow and you create the 2-dimensional array and then improve upon it, it will make it very straightforward and very easy. You're going to see that process when we build this application. The 2D array will take the most time because we're setting up everything. After that, adding the other elements, the other dimensions, is relatively straightforward and fairly easy when you look at it from that standpoint. Here's what our 4-dimensional array looks like in an application. Let's bring one up. Look at the live piece right here. At any given time, we're looking at a company and the years and the data that's sitting in there. What does that data look like? This is my 4-dimensional array, and if you look at the elements in here, we can go way down. It's got quite a few going through there. Something of about 600 different elements in here. We've got actually 1,214 characters in there when we start doubling it up. So you look at all that, and it's all sitting out there like that. So again, the saving and the retrieving of it using the nested loops, the 4 nested loops, allows it to be possible to read the file and then actually write the file as we're going through this piece. If we look at this thing, we can look at any year. We can also look at any company, YMCA. And here it is, YMCA 2023. Let's go ahead and unlock it and put some numbers in here. Let's put in 25.23 and tab down and put down 12.34. Go over here and put in 1,234.78, and over here put 987.45 here, and that's enough. We'll lock the grid. There's our answers are getting there. We can save that file so it's there. It's written to disk now, but it's also out in the array, and we can go away from it. Remember, YMCA 2023. Remember that little guy here. Let's go to a different company. Let's look at Fred's here and look at his 2029. Nothing in there right now. We can certainly put in some data here. Just put something simple in there like a 10 and a 5 and lock it like that. We get our 5 down here. We will then save that. And let's go back to our YMCA 2023. And I'm getting right back to those numbers that I put in a few minutes ago. So it allows you to go to any company, especially an accountant. This is ideal, and pop on there and look at Google stuff, and look at the different years, up to 10 years of data, and be able to get all that on a simple grid that's 3 by 4 long. Now, consider this: if you were an accountant and you were actually creating a budget for a client company, you could have, again, all of the assets, all of the income, all of the liabilities, all on this big grid, and have each month, so January, February, March, April, May, even weeks. You could all 52 weeks if you wanted to put them across the board here, and be a fairly complicated application and confusing, but it could all be there, and you could have it for every single company that was your client company, and you could have it for as many years as you want. Now, 10 years is not a limit. You can certainly go beyond that. 5 companies is not a limit. You can certainly go beyond that. So that's what makes all this possible, and it makes the need for, by using a a multiple dimensional array, kind of obvious that this has some definite benefit for making things look easy to the user, even though there's a complication behind it. But knowing how to do this, how to make it simple, is going to make you as a programmer someone who can control this and make it easier for your user. Next, we're going to go into actually creating this. We'll create the two-dimensional array, and then we'll expand upon it, make it a two-dimensional array, three-dimensional array, and then we'll make it a four-dimensional array. And I think it'll all make sense. Okay, in our example, we always had the two-dimensional array there. When we added the third and fourth dimension, it made sense. I've got a series of videos that will take you through the creation of what you saw today. They will be in the applications section of the website when you're ready to take them on. I'll see you next time. Thanks for watching. And don't forget to use the website for easy access to all my videos. If you get a chance, please subscribe. That way, you'll be notified when something new is available. We'll see you in the next video. Take care.